Let's set up the geometry for our conveyor from an existing drawing. If you right click on any of the carry flights, you can see there's an option to insert flights from a drawing. First thing I'm going to do here is delete 2 of the flights in this existing file that I'm looking at. So I can't delete all 3 of them. I'll have to always have at least 1 carry flight. So we'll start with this first flight and then we'll insert a drawing. In this case I have a drawing of a conveyor here traveling from the left side of the screen to the right side of the screen. It's a downhill conveyor, and I can zoom in on it. See here, it's a very simple profile. And what I need to do to import this drawing is I need to create a layer in my drawing called conveyor line. I've already done that in this case. You can see there a layer called conveyor line, and that layer has been made active. So there also needs to be the active layer in our drawing, and we're going to save this as a DXF file format. So we have the active layer conveyor line. I'm going to pick the polyline command, and I'm just going to go in here and snap in some points along the carry side of this conveyor. I'm not going to be real accurate where I put them. Just find some points along the line here. And the discharge pulley. Enter. So now I've created this yellow line here that represents my poly line of the carry side of the conveyor. I'm going to save this as a DXF file. A DXF file is what we need to import into our program. So example.exf. Okay. I'll open Belt Analyst back up here. Actually, I need to close my my drawing, and now I'll bring Belt Analyst back up here. Insert flights from drawing. Example.exf is what I just created. It just went in and pulled off all the X and Y coordinates for that drawing. I can indicate what the input units was in this case millimeters. You can see the XY coordinates in millimeters, and now it converts those XY coordinates into length and lift coordinates in meters, which was what Belt Analyst reads. So you can see flight 1 through 11. If I click OK, you'll see those flights automatically being input into the program. This indicates that since it's a downhill conveyor, it needed to have a brake. And you can see flight by flight being added, equal and opposite flights on the carry and return, and 8 flights have been added. So I can adjust my belts here. I need to have a steel cord belt. The fabric belt wasn't big enough, and you can see I inputted geometry from that drawing. I started out with this 100-meter flight, so I can delete that flight. That's the one that was there when I started out, and now I've input this downhill conveyor. Now if I'd like, I can go into the return run and start putting in the exact details of the return run. If you remember right, I won't do this exactly, but I'll switch the return flights into user mode. I will insert a flight. I'm going to make this flight right here the calculated return flight, so whatever I do in this area will be deducted from flight number 13. I'm going to go back minus 0.3 degrees. I'm going to go back 10 meters and add my first spin pulley. I'll just put the take up in here. I'll insert another flight here between the take-up and the bin, and I'll drop that down 3 meters in a vertical direction. I will insert another flight and make it come back up 3 meters to the return pulley. And now if I look at the right click on the drawing and look at the 2D profile of the drive area and the take-up area, you can see I have somewhat correct configuration, not quite correct. If I want to make that exactly correct, I can come in here to my pulley wizard profile, and it added one belt segment for me, and now I can automatically come through here, and it automatically tries to fix all these for me, and you can see it did a pretty good job of fixing them right there. And that's pretty much what I'm looking for. So hopefully it got everything fixed. I can come back to my 2D profile and check it out again, and you can see it looks like somewhat like I'm looking for. Since we're setting up an existing conveyor, there's some other things that that we just need to know from the existing conveyor. For instance, the belt width, how wide the belt is, 1200 millimeters, the belt speed, the tons per hour, the capacity of this conveyor, design capacity, the low temperature, that's the lowest ambient temperature this conveyor will ever run in. We want to make sure we have the right horsepower, and that's dictated by the low temperature requirements. The actual description of our material, again, we just need to know what material it is we're running, the density, and we really want to know the lowest density, so we have the highest percent loaded in our system. We also want to make sure we have the lowest surcharge angle. In other words, how flat will that material flatten out on the conveyor when it comes out of the discharge point. The lower that number, you see the higher the percent loaded. At this point we're at 98% loaded. If this is a 20-degree surcharge angle, we're at 85% loaded. So we just want to make sure we're on the low side. We get those numbers from our client who should know the material they're carrying, or you can go to some books such as the Conveyor Equipment Manufacturers Association and look up particular materials and see what typical design factors are for this material. We've talked about the geometry and setting the geometry of the conveyor up properly. The belt, right now we're in auto mode, so it's selected a belt from a default database. We should always make sure that we have that particular belt properly characterized, and that is, once the belt's selected from the manufacturer, we want to make sure we have the proper cover gauges and the proper belt weight, and this can differ from manufacturer to manufacturer. We want to make sure we have the correct modulus of elasticity. And you can see as we put these in, the inputs turn dark blue, which indicating we have the correct inputs in here. And even if you know the manufacturer of the belt, I would suggest we go to custom, and actually idlers the same way. If we don't have specific idler manufacturer data in our program, as would be possibly in like this particular set of data, if we're using generic data, we want to make sure that we have properly picked the idler that meets this criteria. And since the idlers this is an existing conveyor, we should be able to find the manufacturer and find out if the seal drag and the idler load rating is proper for this particular conveyor. We have a sign calculation now. We're running power requirement of 176 kilowatts, but now we want to make sure that we get the proper motor size in here, lagging, the proper type of lagging, the thickness of the lagging, the proper motor configuration, synchronous RPM of the motor, the efficiency of this particular drivetrain, the mechanical efficiency, and also the high-speed inertia of the drivetrain. And we want to make sure it's gray, that's in user mode, and that we've picked all the criteria of the motor properly. Same with the take-up. Since it's an existing system, we should know what the weight of the take-up is. If it's a gravity take-up, we should know how much weight's there. If we don't, we want to make every possibility that we understand that, even if we have to go out and lift the load and measure the weight, because that's very important. And of course, pulleys. We have existing pulleys, so we need to make sure that we have proper pulleys for the application. In this case, we've selected a belt here which appears to have require more than a 450 millimeter pulley. And you see, if I set those back to the default values, you can see that they need to be a little bit larger. In this case, our belt needs to be a little bit larger, so we'll go back here to auto, reselect the belt, and also in this case reselect the pulley diameters. Once we get these set, we want to be in user, we want to be gray, we want to make sure we have all the shaft diameters and bearing diameters properly selected for this particular application, and any vertical curve radiuses. We have convex and concave curve radiuses in this application, so we want to make sure that we have these set for both the carry and the return side. So now as we start going through our what-if calculations, we have everything set, we have all the components input properly, we have the geometry input properly and the material input properly, and now we can save this file and begin doing our evaluation of this conveyor to see if everything's proper.